Today, organic chemistry part 1. I will try to cover the introduction part as well as, if possible, alkanes as well. But mainly, I will focus on how to write the names if they give you the structures, as well as how to write the structural formulas. Because 5 marks are fixed in that. So, whatever you learn in this or don't learn, but this naming and writing the structural formulas, focus and concentrate on that part, because 5 marks, that too in section A, you cannot skip that, you know. So fixed questions are there. If you do it and understand it correctly, those 5 marks will be in your pockets. Okay. So introduction part में, organic compounds are those compounds which must contain carbon. So it is also called as carbon chemistry. Organic chemistry is also called as carbon chemistry. All the organic compounds what we are going to study, they all are covalent compounds, and we have already studied the properties of covalent compounds. Same thing will be there for organic compounds as well. You know, they mostly will be existing as gases, liquids, or soft solids. They are insoluble in water but soluble in organic solvents. Low melting point, boiling point. This one property is different here. They show isomerism. Okay. And when they burnt in air, they produce carbon dioxide and water. They are highly inflammable. Okay. Means catch fire very easily. So all the fuels what we are using, they are organic compounds. Petrol, diesel, kerosene, natural gas, you know, these all are organic compounds only. So why carbon? What is the speciality about the carbon? If they ask, 2 points: tetravalency and catenation. So when you write electron configuration of carbon, 2,6. So for carbon, 2,4. For carbon, it has to either gain 4 electron or it has to lose 4 electrons. Both of these require very high energy, which is very, very difficult. Therefore, carbon will not form ionic. Usually, there are exceptions. But most of all the organic compounds what we are studying, it is formed by sharing of electrons by the carbon. Therefore, we call it as covalent. You know, catenation means carbon can form a long chain with its own atoms, like this. But this catenation is not only shown by carbon, some other elements also show, but no other element can show how much it is shown by the carbon. Okay, carbon can form like around 60 carbons chain, 70 carbons chain, like this. Okay. So here, what is catenation? I have also observed yesterday that writing the definitions, most of you not get all the 3 marks. So what is given in the book, as it is, you have to write. So here catenation, they can ask you the property of self-linking of carbon atom with other carbon atoms through covalent bonds. So in this process, it can form a straight chain, branched chain, or even cyclic chains. Hydrocarbons. Whatever we are learning here, all of them are hydrocarbons. Hydrocarbons are those which contain hydrogen and carbon only. But sir, we are also studying acetic acid, alcohols. They contain oxygen, you know. So those we will call as derivatives of hydrocarbons. If any other atom is there, but it is also formed by the hydrocarbons, we call it as derivatives of hydrocarbon. So based on whether the chain, whatever carbon chain is there, whether it is an open chain or closed chain, we call it as open chain hydrocarbon as aliphatic. Closed chain will be cyclic, we call them actually. Okay, cyclic compounds. Under that we have aromatic. Okay. But what we are studying here, only about the aliphatic. Under that, saturated, unsaturated classifications are there. We will study them. One example, aromatic are the cyclic compounds, but which they contain at least one benzene. Okay, benzene, yes. So in the aromatic compounds, you just remember the structure of benzene, C6H6. So you know how to draw the hexagon, no? So give carbon atoms to the corners of the hexagon. like this. I will give you reference here. You can see. So corners, you are writing carbon atoms and each carbon atom must contain one hydrogen here. 6 carbons के लिए 6 hydrogen you write. And carbon's valency, remember in organic chemistry carbon's valency is always 4 na. So there should be 4 bonds around the carbon. In each and every structure make sure there are 4 bonds. It may be all single bonds, there may be at least one double bond or maybe a triple bond also. But overall around the carbon should be 4. If you see this structure, each carbon atom has 3 bonds, right? It is not stable. So what you have to do, alternate double bond you write. When you write alternate double bond, you will get the carbon, all the carbon 4 bonds. You can write the double bond anywhere, but it should be alternate. Okay, so this is the structure of the benzene. And which one you call as aromatic? At least one benzene ring should be there in it. That will be called as aromatic. Okay, but sir, if there is a compound like this, it has no benzene ring, but it is cyclic. Do you call it as aliphatic or aromatic? You can't call it as aliphatic or aromatic. It is not aliphatic also. We call it as alicyclic or simply call it a cyclic compound. Okay. Aliphatic is only open chain. It should not be ring or closed. In the cyclic only you have alicyclic as well as aromatic, two categories. Excuse me. Got it? So alicyclic means it has no benzene ring, but aromatic must have benzene ring in it. Okay. So talking about the differences between saturated and unsaturated, very simple. Try to understand, no remembering. Okay. So carbon is there, must be there in organic. If carbons, all the 4 valencies are satisfied by only single bonds, okay, then it will be a saturated compound or hydrocarbon. But at least one carbon to carbon double bond or carbon to carbon triple bond. You have to mention carbon to carbon double bond or a triple bond, because carbon can form a double bond with oxygen also, triple bond with nitrogen also, but these are not, we don't call them as unsaturated. This, if it is there, then only it is unsaturated. Okay. So the valencies of at least 2 carbon atoms are not fully satisfied. So we say that when there is a double bond or when there is a triple bond, we say that it is not fully satisfied. When it is fully satisfied, when it has all the single bonds. Valency is okay, but it is not stable. And what we know in chemistry, everything wants to become stable. Therefore, always unsaturated compounds want to become saturated. So because saturated compounds are already stable, they are less reactive. Whereas unsaturated compounds, they want to become saturated, therefore they are more reactive. So if they ask you why they are more reactive, because of the presence of electrons in the double bond. One second. Electrons in the double bond or a triple bond. That makes it more reactive. Yes, Danish? Hmm. Tetravalency is satisfied, but we say that whether the compound is reactive or less reactive. है ना? So whatever is attached to carbon in a triple bond, if there is a triple bond, that triple bond is not so stable. Why? Because you are holding large of electrons between the two nuclei. Okay, so huge electron density will be there between the two nuclei, which is very difficult for two nuclei to hold more number of electrons. Than holding only 2 electrons by the 2 nuclei will be easier. Okay, therefore it makes it more reactive. Hence, whatever it is attached to it, it will react and becomes saturated. Okay, Iona, you have any question? Alkynes. We'll see in the alkynes part. Okay, specific name is nothing like that. But you first member of alkane is called as acetylene. So you may call it as acetylenic bond. Okay, the triple bond you can call as acetylenic bond. Okay, so this is the difference between saturated and unsaturated. Third difference is what kind of reactions they undergo. So saturated will undergo substitution, whereas unsaturated will undergo addition. This is simple thing also you people get confused. Huh? Okay, so at least remember saturated substitution. SS you can remember. Hmm? At least that much you try. Unsaturated undergo addition. Why? When they undergo addition, they will become saturated. So unsaturated always want to become saturated. Therefore, they undergo addition reaction. We will see what are substitution and addition reactions. Alkanes. Saturated compounds के लिए examples are alkanes. All the alkanes. Unsaturated के लिए alkenes and alkynes. Because alkenes contain carbon to carbon double bond. Alkynes contain carbon to carbon triple bond. Okay, whereas saturated alkanes contain only single bonds. General formulas will write here: CnH2n plus 2. Reduce 2 hydrogen, you will get CnH2n for alkenes. Reduce 2 more hydrogen from this, CnH2n minus 2. Okay, so these are the general formulas. So you can keep on putting n values, you will get the first, second, third members formulas. Remember, for alkenes and alkynes, n value starts with 2. Okay, but for alkanes, n value starts with 1. Why? Because at least 2 carbons should be there. So n number represents what? Carbon atoms, no? So for alkenes and alkynes, at least 2 carbons should be there. Okay? So these kind of questions, C10H18 is. So you have to check to which general formula it fits to. That will be the compound here. Alkyne, C10, 10 to 20 minus, it is alkyne. Unsaturated hydrocarbons undergo what type of reaction? Anybody can answer. Addition reaction. Very good. Number of CH bonds in ethane. So we have already learned. See, when you write the structural formula of ethane, this is the structural formula. You know. So they have asked here in this how many carbon hydrogen bonds are there. So this is 1, 2, 3, 4, 5, 6. So 6 is the answer. Instead of this, if they ask you number of single bonds, then carbon to carbon bond also you have to include, then it becomes 7. Okay. These match the columns. Alkynes general formula will be fourth. You know, CnH2n minus 2. Alkane will be CnH2n plus 2. Iron, the metal that forms two types of ions, you know. This will be 1 mole. 1 mole is number of molecules. This one will be number of molecules. Metal, an element with electronic configuration. ठीक. Then metal, do you match it with the metal that forms two types of ions? No, na. The most better answer you have to find. Correct? Okay. Find the odd one out. Valence is not a criteria. So again, based on three substances will be like alkanes, alkanes, alkynes. Any one group they belong to, and one will be different. So this is methane, this is ethane, this is pentene. So this should be the odd one. Formic, nitric, acetic, propanoic. So here nitric you have to remove because nitric is a mineral acid. Remaining three are organic acids. Okay, homologous series, most of the time they have asked the definition. Okay, understand the definition. Simply don't write whatever you want. A homologous series is what? It is just a, in the periodic table we have similar reacting elements in one group now. So similarly here they have made a group of compounds which behave similarly, which can obey one general formula, and in them successive members differ by the CH2 group. Okay, so here homologous series is a group or a family of organic compounds. This is only for organic, having similar structure, similar chemical properties, in which successive members differ by a CH2 group. So alkenes, alkynes, alcohols, carboxylic acids, all of these what we are studying, they all are one homologous series. Okay, so for example, alkane is there. So they have given here each homologous series can be represented by a general formula. Alkane can be represented by CnH2n plus 2. Successive members differ by a CH2, and if you count the value of CH2 by atomic masses, carbon 12, hydrogen plus 2, 14 AMU. So first member you take CH4, second member C2H6. What is the difference? CH2. Third member C3H8. What is the difference? CH2. So it keeps on going. Not only for alkanes, same thing happens for alkenes, alkynes, whichever homologous series is there, successive members differ by the group CH2. Okay. Other than this, if there is a functional group, say for example alcohol, so all the members of alcohols will have the same functional group, OH. Okay, so there will be a gradual change in their physical properties, but the chemical properties are similar. Physical properties like melting point, boiling point. So remember, in organic chemistry, as molecular weight increases, okay, melting point, boiling point also increases. As molecular weight of a substance, say we can say here methane has less melting point compared to ethane, because ethane has more molecular weight. Same thing happens with the next member. Isomerism will come back. Nomenclature, this is the one which you have to focus. Okay, if you already know, fine. If you're not doing one single mistake, then very good. Otherwise observe here. So main three parts of any organic compound will be first root word. Root word. The root word is given by the number of carbon atoms. Okay, not in the whole molecule. We will select one longest carbon chain. In that we will count how many number of carbon atoms are there. That will decide the root word. I hope you already know. If it is 1, you call it as meth. 2, eth. 3 carbons, prop. 4 carbons, but. 5 carbons, pent. 6, hex. 7, hept. 8, oct. 9, non. 10, dec. Okay. Meth, eth, prop, but, pent, hex, hept, oct, non, dec. So this will give you the root word. So once you found the root word, second you go to suffix. In the suffix part, again depends on if there is a functional group, we will have 2 suffixes. Otherwise only one suffix. So I will divide it into 2 parts. One we can call as a primary suffix, which is always there. Okay. Another one will be secondary suffix. It will be written only when there is a functional group. Okay, that part I will explain later. Only when FG functional group is there. So, but primary suffix is always there. So, which are the primary suffix here? What it depends upon? It depends upon type of bond between carbon atoms. मतलब only single bonds are there. All single bonds. We will end it with ane. Alkane. Single bonds only. Double bonds are there between carbon and carbon. If it is belonging to alkene, so ene you have to add. So if there is a triple bond, yne we have to add. है ना? Alkane, alkene, alkyne. Say for example, meth, one carbon and there are all single bonds, methane. है ना? Eth is there, two carbon atoms, but there is at least one double bond is there, ethene, propyne, like this. Then in some cases, we also need to write the prefixes. So when we write the prefixes, when there are substituents. Now what are substituents? Okay. So imagine you have written one compound is given. Okay. You have selected the longest carbon chain. Anything apart from the longest carbon chain, that will be considered as prefix or a substituent. Sorry, it will be considered as a substituent. Don't worry about the hydrogens. Okay, hydrogens are simply there. If there is any other thing like halogen is there or any other carbon atom attached, but it is not in your main chain, okay, like this, then that also comes as a substituent. Okay. So here we have two kinds of substituents. First one, it will be alkyl group. So where this alkyl word comes from? It comes from the alkane. So when alkane loses one hydrogen, it will form alkyl group. For example, CH4, one carbon, all single bonds, methane, methane. If you remove one hydrogen from it, CH3 with one bond it needs. With that bond only, it will go and attach to the main chain. So from methane, if you remove the H, you will get a methyl. Simple. Alkane से alkyl, methane से methyl, ethane से ethyl. No, remove it. C2H5. So this is ethane. Removing one hydrogen will give you ethyl. Okay. So you don't worry more than ethyl and methyl. Okay. But it continues propyl, butyl. But for you, they will not give you other things. Remember, so ethane, how you can write sometimes, they will give you ethane. This one is also ethane only. If you remove hydrogen from this, it will be CH2, CH3 like this. So, but you have to write dash here in front of CH2 because that requires one more bond. है ना? No, you have to write that. Because see, keep forgetting means what is this? Here you have like this. Okay. What you did, you just removed one hydrogen from this. Only hydrogen you removed. That bond should be there, no? Because carbon needs four bonds. So with this bond only, it will go and attach to the main chain. Okay. Chalo. So instead of giving you C2H5, they can also give you CH2, CH3. Then that also ethyl group only. Okay. So this is the basic of how to first write the simple names. Okay. Chalo. We'll take some examples here. They will give you the structural formula like this: CH3, CH2, CH2, CH3. Okay. So this is we call as a condensed formula. Condensed means you don't show the carbon hydrogen bonds. Okay. But they will not ask you to write condensed. They will ask you to write the structural formula. But let's first understand how to name it. So you have to select the longest carbon chain. So here only one chain is there, straight chain. So 1, 2, 3, 4. So the root word. Hmm. 4 carbons के लिए ब्यूट. हाँ. And for suffix will be all are single bonds. Always remember, hydrogen can never form a double bond. So don't worry whether it is condensed or something. When there will be a double bond, it should be between carbon and carbon only. So here all are single bonds. So you have to add the suffix ane. So the name of this compound. There is no prefix. Nothing is attached to the main chain. So butane. Okay. So this is the name of this compound. And here whenever the letter comes first, it should be capital letter. Second one. Could you go back to the previous slide 1 second? Yes, sir. So second one, see, I will give you like this. Okay. Now also first rule, what you have to remember, we have to select the longest carbon chain. So you select it here, 1, 2, 3, 4. 4 carbons. You can try it from, start from here also. 1, 2, 3, 4. Again 4 only. If you do reverse, it is same thing. You know? So you can take any one here because both are giving you 4 only. Okay. So I will take the green colored one. Now 4 means a root word you have to keep but. Okay. All our single bond suffix will be A and E. This time don't write again butane because you have something extra here. So this CH3 group is attaching to your main chain. So this will be considered as a substituent. And what we know for substituent, it is an alkyl group. CH3 means methyl group. CH3 means methyl group. So this is a methyl. So prefix will be methyl. But when you are writing the prefix name, you have to write the position of the carbon to which it is attaching. So this methyl group is attaching to the second carbon. So you have to write 2 dash methyl. So now you follow the pattern. Prefix, root word, suffix. So prefix is 2 methyl, 2 dash methyl. Here M should be small because first number is coming. Okay. Then butane. Butane you write together. So the name of this compound is 2 methyl butane. Anybody not getting this? Simple example I am giving you. ठीक है. So between the methyl and the butane should there be a comma or a dash? No. The dash will be between only the letter and the number. Comma you don't write anywhere. So you only use comma use will be to write the numbers separately. There only. Okay. Now you see, you have to try yourself what is the name. Okay. Okay, let me just. Yes, Danish. Yes, I got you. Yes, tell me. I said pentane, right? Pentane. Okay. Anybody else got other answer? No, sir. No? Same answer. Some people, what they do mistake, they will number this like this. So they will write 1 methyl butane, which is incorrect. Why? What is the first rule you have to follow? Select the longest carbon chain. So you have to start from here. See, they can give you anywhere. Don't worry. It may be a straight chain, it may be a branched chain, nothing. Okay, you should not worry about that. Instead of giving you like this, they may give like this. Then also you should not bother about it. 1, 2, 3, 4, 5. So 5 carbons in one chain. Okay, no other substituent attached. Then it is pentane. Okay, if I give you same compound, CH3, CH2, CH, CH3, CH2, CH3. What is the name of this compound? So it's 3-5 pentane. pentane only. 5 carbons. So again you select the longest carbon chain, but now you know that this is not in your main chain. So this is a substituent. What is the position? 3. So it is a prefix 3-methyl and pentane. Okay. So these are simple examples. See, in your main exam, simple questions only will come. But in your Greenwood High paper, they give you difficult questions. ठीक है, see here. You have to expand. When they ask you to write the structural formula, you have to expand it. Okay, so these are the rules. First, you observe here. First rule is you have to select the longest carbon chain, and that longest carbon chain need not to be a straight chain. Okay. Second one comes numbering of the longest chain. So you can see here I numbered it, but on what basis we have to number it? So you have to give preference while numbering. Imagine this preference you have to remember. If there is a functional group, you have to give preference to functional group. Means functional group should get the least possible number. Okay, least possible number it should get. Okay, functional group is not there, but it is either an alkene or an alkyne. Means double or triple bond is there. Then you have to give preference to that. Both are not there, only substituent is there. Then you have to give preference to substituent. Preference matlab what? Least possible number. Okay, let me give one example for this, then we'll come back to third one. Say if I give you CH3, CH. Okay, this compound. So now what you have to do, first to select the longest carbon chain. Okay, okay. So 1, 2, 3. Let me just change it little bit. CH के position में I will give one Cl attached here. ठीक है. 1, 2, 3, 4, 5. 5 carbons. Now numbering, whether you have to number it left to right, or you can also number it 1, 2, 3, 4, 5. Correct? No, you have to number it first. Okay. Now you should know which one is correct way. So what I told you, if there is a double bond or a triple bond, do not worry about the substituent. You have to give preference to double bond. So, left to right should be correct, because in this case, the double bond where it starts here, second carbon. If you do from right to left, it will get the third position. Means where the double bond is starting, that number you have to count. Third position, which is bigger, but we want the smaller number. Therefore, the correct way of numbering is, in this case, left to right. Okay. Now, how to name this? Same thing, whatever we used previously. Okay, but you have to write prefix first. Prefix will be same. 4-chloro. Okay, I didn't tell this one. See, one is alkyl group substituent. Another one can be your halogen group. Okay, if halogen is attached, simply we call it as halo. Chlorine is there attached, chloro. Bromine is attached, bromo. Okay, fluorine attached. So before, when we look at halogen as well as the functional group, we always look at functional. Yes, whether halogen or alkyl group is attached. Okay, you have to give preference to functional group. Even if there is a double bond, then also you give preference to functional group. That's why this is a preference chart. This is for numbering. Okay. So let's complete this first. So the position 4 contains chloro. So 4-chloro, 5 carbons. So pent is the root word. Second position may we have a double bond. So for writing the double bond and triple bond, we have to mention the position of the double bond or triple bond while writing the name. So where is the position here? So don't write pentene. You have to write pent to ene. Okay, what this 2 is telling us, it is telling us that double bond is in at the second carbon. 4 is telling us that chloro is attached to fourth position. Okay, some people do mistake what? Reverse numbering they do. So they will write 2 chloro, pent 3 ene. MCQ they can give you. So this will be incorrect. This will be correct. Yes. If there is no functional group. This is preference chart, remember. Okay. Take this next one. This time see CH3, CH2, CH2, CH, Cl, CH3. Okay, so this is one, this is another one. Here there is no double bond, there is no triple bond, there is no functional group. So then now you have to give preference to the substituent. Now also don't do left to right. Now we have to see in which way if you number, the chlorine will get the least possible number. So that will be reverse. 1, 2, 3, 4, 5. So when you do this, it will get 2 chloro. If you do left to right, it will get 4 chloro. But this time only substituent is there, then you have to give preference to substituent. So this will be 2 chloro. Pentane. Pentane. Come to the next one, substituents naming. So if the same substituents are present, then more than one time, then we use di, tri, tetra, etc. And different substituents are present, we use alphabetical order. So what is this? Let's understand with example. I will explain when I take the functional group examples. Okay? Everything all it will get confused. Only 3. Okay, but before that, let's take these things. See here, when there are same substituents present, more than one. So common example they have asked many times is this one. Okay. So first rule is what? Select the longest carbon chain. So there are different ways to select here. You have to see all the possibilities. So you can select this. Okay, 3 are there. You can select this, then also 3 are there. So if you select this, then also 3, this, all are 3 only. So it doesn't matter in which way you select it. I will do it from left to right. So here I will take 1, 2, 3. So if this is our main chain, then what about these two? These two will be substituents. And you can see both of them are methyl groups only. And both of them are attached to second carbon only. So in such cases, how we write the name 2, 2. Okay, because 2 substituents are there. How many substituents will be there? Those many numbers we have to write, positions. If only one substituent means 2. But here both are attached to second carbon, so 2, 2 dash. Di we have to use 2 methyl groups. Di, methyl, 1, 2, 3. Prop, ane, all are single bonds, so ane. What you do mistake, D you should not write capital. Okay, 2, 2. Or some people forget to write positions 2 times. They simply write 2 dash dimethyl. See, if you're telling dimethyl, matlab there are 2 methyl groups. So each substituent should get the number. Okay. Another example, CH3, C, C, CH3. Okay, H here, CH3, CH3. Okay. Again, select the longest carbon chain and all that same. So 1, 2, 3, 4. This is where I will select it. This will be longest carbon chain. Now you see again this and this. These two are substituents. Now they are on different carbon atoms. So you have to write the same way. 2, 3. है ना, dimethyl, 4 carbons, butane, है ना. The name of this compound will be 2,3 dimethyl butane. Understanding? Anybody not understanding this? Clarified. Okay, one example here. This I think I gave also. This one. Now don't write the position because there is only one carbon, na. If there is more than one carbon, then you need to number them. If there is only one carbon, it is understood that whatever substituents are there, it is attached to that carbon only. So here how many carbons are there? 4. 4 के लिए we use tetra. And all are substituents halogens. So halogens के लिए chloro, है ना. And single carbon methane. All are single bonds, na, ane. Don't worry whether hydrogen is there or not. Doesn't matter. Whether single bond is there, how many carbons are there. Okay, substituent is what? So here why we are writing tetra? Because there are 4 chlorine atoms attached. If there are 3, trichloro. You know? So this is the IUPAC name for this one, carbon tetrachloride. CCl4 is carbon tetrachloride is a common name. IUPAC name is tetrachloromethane. Okay, let's try. This time write the position. Okay, 1, 2, only 2. Do not number the hydrogens, huh? Only carbons we have to take. Okay, what will be the name of this compound? Isha, can you try? How many bromine atoms are there? So tetra, bromo. How many carbons are there? 2. 2 के लिए रूट वर्ड eth, है ना. And all are single bonds. So what is suffix? So can you tell the name? Tetrabromoethane. What you forgot? The positions you have to mention. Very good. Yes. So this time we have to mention. Okay, tetrabromoethane. So when you don't need to worry, one only single carbon is there. So no need to write the position. But if you still want to write, sir, I want to write, then 1 comma 1 comma 1 comma 1 you can write. All are on first one carbon only. ठीक है. In this again another example is when there are two different substituents, then what we do. For example, C, Br, CH, CH3, CH2, CH3. Now you will select the longest carbon chain. Again, how to number? Both the substituents should get least possible number. So 1, 2, 3, 4, 5. Correct. Okay. So now we have to use now, sir, whether I have to write 2 bromo first or 3 methyl first. So 2 bromo. If I change this, then what you will write first? Bromo. So whether bromine is on the third carbon or on the second carbon, we have to use here alphabetical order. Alphabetical order for substituents. Means whose alphabet comes first? Br ka bromo. So B comes first. This one is methyl, M. M comes later. So whether bromine is on second carbon or third carbon doesn't matter. You have to write that first alphabetically. So but the number you have to write same. 3 dash bromo dash second methyl. So this time be careful. Prefix में you have to write both of them. 3 bromo 2 methyl then 5 pentane. Okay. Then it becomes numbering will change. Let's take that. You are asking me this CH3 CH. Yeah, got it. C double bond CH CH3. Okay. This time you have to give preference to what? Numbering, you have to give preference to double bond. Your numbering will change now. One, two, three, four, five. Okay. Now also bromine is getting 3 only, but methyl is getting 4. So name will change now. Alphabetical order only we have to use. 3 bromo, 4 methyl. Now position of the double bond is second, not third. Pent, 2 in. Where it is starting, second carbon, na? So that we have to write. Pent dash 2 dash. 2 dash penting can also be written. Okay. So this what I'm giving you is very difficult questions, but in the exam straightforward questions will be there. Most common examples, like dimethyl, if it is mostly dimethyl questions they have asked, dichloro, these kind of things. Okay, let's take the last functional groups if they are present. Hmm. So these are the three functional groups. That we'll see. These we are naming enough till we are not writing the structures. Still naming, huh? So here see three kinds of functional groups: alcohol, aldehyde, carboxylic acid. Alcohol is OH, aldehyde is CHO. CHO you have to remember expanded formula here. C double bond OH. Whenever O is there, it is double bond. Here COH is C double bond O, single bond OH. Many of you have got confusion. Some people write C single bond O here and double bond O here and H. Understand, oxygen can never have triple bond. Valency of oxygen is 2 now, so it can have two bonds. Bonds depend upon the valency of the element. Carbon's valency is 4, so it can have 4 bonds. Oxygen valency 1, it has only one bond. Oxygen valency is 2, sorry, it has only 2 bonds. Hydrogen's only one bond. You know? What you're asking? No, only these three. Okay. So here secondary suffix I told you na in the first one, only when there is a functional group you have to also add the secondary suffix. So alcohol ends with OL, so that is its a secondary suffix we have to use. Aldehyde starts with AL, so AL we use for a secondary suffix. Carboxylic acid may OIC acid means oic acid we have to use. Let's take the example of them. Simple example CH3OH. To follow the same rule, only one carbon is there, root word is meth, है ना? All are single bonds. OH will be what? Single bond only. Then to don't worry whether what it is has, but it should be carbon to carbon, है ना? So here all are single bond. Primary suffix is A and E we write, and alcohol के लिए secondary suffix you have to write OL. There is no prefix here. Okay. Now when you write the name, this E you have to remove. So what do you write the name? Methanol. Methanol. Okay. Same way CH3 CH2OH. What do you write? Two carbons Eth we write. Single bonds in. Alcohol OL. So E you cancel out. Ethanol. Not ethaniol. Huh? Ethanol. That's it. And be sure to write OL and AL clearly in the exams. Because this one letter will change the name. Now, if there is more than two carbons after methanol and ethanol, you want to write the propanol, you have to write the position of the functional group also in this case. So, if there is like this CH3, CH2, CH2, OH. So now this OH can be on this carbon or it can be on the second carbon also like this. Therefore, it is important to mention the position of the alcohol. So in the functional group part, only alcohol position will change. But for carboxylic acid, for aldehydes, It is always one only. I will tell you that. So here numbering will be from this side. There is no substituent. Okay, propanol or propan 1 all, or 1 propanol can also be accepted. So where you are writing the number after writing the primary suffix an, and between the primary and secondary suffix you are writing the position of the functional group. Okay, that tells that okay, OH group is on the first carbon. Similarly for this one, Ruhani, can you tell me the name of this second one? Hmm. Yes, propan 2 all, or you can simply write 2 propanol. Okay, again mistakes are, if you don't understand this, you will write prop 1 all, you write and you don't write only. Okay, so follow what is the thing I told you, prefix, root word, primary suffix, secondary suffix, then nothing will be missed. One example with substituent I will give you, where you have to give preference to alcohol. Say here I will write Br. Now how to number this? Don't give preference to bromine. You have to give preference to alcohol. Numbering 1, 2, 3. Okay. So then you will write 3 bromo propan 1 all. ठीक है? Understood? Huh. Even if it is one carbon one, we can also miss one, writing one. Propanol, if we write, it is understood that okay, the OH is on the first carbon. But you people are still learning, na? To keep practicing to write this. Otherwise, you will forget. So, talking about aldehydes. Aldehyde में mainly first member, second member only they will ask you. ठीक है? Understand it. So, C double bond OH. This is the functional group. So this dash is there, na, means it needs someone to get attached with. The first member, if you want to write, you have to give hydrogen to it. H. C double bond O H. You want to get the next member, increase the number of carbons. So you will write CH3. C double bond O H. Okay, I'm expanding this, but you can simply write HCHO. Okay, or CH3CHO also they can give you. What is the name of this compound? So again follow the same rule. How many carbons? 1. Meth. All are single bonds. Don't consider this double bond. Double bond should be between carbon and carbon, not between carbon and oxygen. So primary suffix is N. Okay. And what is this group? Aldehyde. So secondary suffix is Al. So cancel out this E. The name of this compound is methanol. Okay. Similarly, second one will be ethanol. 2 carbons here and here. This carbon you have to consider. Whichever carbon is there, that you have to consider. Some people don't consider this. They will consider only this. They write this one methanol, which is incorrect. Alcohol ke liye we don't do because there is no carbon. But for aldehyde and carboxylic acid ke liye, you have to consider that carbon also. Okay. For the first member, the common name is acetaldehyde, because they have asked previously, write the structural formula of acetaldehyde. So acetaldehyde is nothing but the first member of aldehyde. Acet means first member. Sorry, second member. Sorry, second member is acetaldehyde. Acetic acid we know CH3COH na. Same way acetaldehyde is the second member. First member is formaldehyde, just like formic acid. So formaldehyde is first member, acetaldehyde is second member. Same like for carboxylic acid if you take. The functional group is COOH. So expanded formula is like that. C double bond O, single bond O and H to oxygen. Okay, or COH you already know. The first member of this is give H to this carbon. H, C double bond O, OH. Second member will be CH3 you give COOH, or I will simply write, you know already, acetic acid. You know. So how many carbons? One carbon. So meth. All are single bond. Primary suffix is A and E. Secondary suffix for carboxylic acid is oic acid. To cancel out this E, what will be the name? Methanoic acid. If you write it, methanoic acid. Second member is eth and oic acid. To cancel out E, ethanoic acid. Common name, this one is formic acid, this one is acetic acid. Okay, so here don't worry about numbering for these things. It will always be one only, because you always start from numbering here only, whatever it is there. For example, if they give you CHBr, okay, CH2, CH2, COOH. So you will always start numbering from here only. 1, 2, 3, 4. So fourth position has bromo. So 4 bromo, 1, 2, 3, 4. 4 carbons means butanoic acid. No need to write butan 1-oic acid because it is always 1. Same thing for aldehyde. Propanol, butanol, pentanol. No need to write 1. Okay, understood? Any doubts in this? 5 marks. 3 usually will be for naming and 2 will be for writing structures. No? Okay. So we will come back and we will see the isomers, types of isomers. Let's continue. So now you know how to write the names if the structures are given. Next we will see also how to write the structural formula if the names are given. But before that we'll go through this concept called as isomerism. Okay. So isomerism is what? There will be two compounds. They have the same molecular formula, but their structural formulas will be different. Okay. Same molecular formula, but different structural formula. That will be called as those will be called as isomers, and the phenomena is known as isomerism. In this, we are learning only about the structural isomerism. In that too, chain and position isomerism. Okay. So chain means what? Two compounds have same molecular formula, but their longest carbon chain will be different. Say for example, they will give the formula C4H10. C4H10. So you have to write possible structural isomers for C4H10. So what you will do, C4H10 is what? Whether you have to see alkane, alkene or alkyne. You know? So this will be alkane. Alkane means all will be single bonds. So now what you do, write one straight chain like this. First carbon skeleton we write. Okay. Now every carbon needs how many bonds? 4 bonds. So make sure you write first all the 4 bonds around the carbon. Okay. Now give the number of hydrogens required. Okay. This is one possible structure. If you see 4 carbons and 10 hydrogens. Now what you have to do, can I change the main chain? That you have to think. Means here 4 are there. Can I change it to 3? Because you can't increase carbons. You have to keep the same number of carbons. You know. So now you see, okay, I will reduce it to 3 and the third carbon I will write on the fourth carbon I will write on the middle carbon. Now again you have 4 carbons. You know. So give the required number of bonds and the hydrogens. So here like this. This you should never forget. Some people give 5 bonds to carbon or 3 bonds. That will be incorrect. And if you write the number and don't write the bond and don't write the hydrogen, then also gone. Hmm? So yes, this is another possible structure. Now you also have to think one more structure. Is it possible? Then means you have to reduce to 2. And where you will write other carbons? Either you have to write here and here. Then it will again be continuously 1, 2, 3, 4. First structure only. You know? So no more structures are possible for this. For which C4H10. Now what you wrote here, these two are called as chain isomers. So chain isomers may the two compounds have same molecular formula, but their main carbon chain will be different. So that you can also know by the name, because root word depends upon the carbon atoms now in the main chain. Chalo, tell me, Tanisha, what is the name of the first compound? Tanisha, are you there? Darshwana?
Yes, sir. First one is butane.
Second member?
Sir,
Second
two
member?
two
Number?
methyl,
Hmm.
two methyl,
Three
propane.
carbons. Propane. Right. So butane and 2-methyl propane. These two are chain isomers of each other. है ना? Hmm. One second. Okay, so these are the IUPAC names. So now you know how to write IUPAC names. है ना? But for these two examples, that is for C4H10 and C5H12, we need to know the common names. So butane is known as N-butane, commonly called as N-butane. N means normal, normal means straight chain. Okay, no branches. And second one is known as isopentane, isobutane. Iso means there will be one branch. But when you're writing the common names, you'll write butane only for both. But if it is straight chain, it is N. And if it has a branch, iso. Why it is important? They may ask you write the structural formula of isobutane, N-butane. Or what is the IUPAC name of isobutane? Therefore, we need to know it. Hmm? So these are the isomers of C4H10. Or if they ask you to write the possible isomers of butane, the first formula you write for butane, then 2-methyl propane. You know? So same thing we can do for C5H12. 5 carbon atoms. Again, what you have to do? Try writing different structures. First straight line, then reduce it to 4 and then write carbon here, or you can write carbon here also. You know? Then reduce it to 3. Then 2 more you can write on the central carbon. So now you may think, so 1, 2, 3, 4, 4 structures are possible. No, you have to write the names, then only you will understand. So I'm writing here first structural formulas. So whenever they ask you to write structural formula, you have to write all the bonds. Don't be lazy in writing the bonds and hydrogens. It may take little bit of time, but you have to write that. Meanwhile, all of you can try naming these compounds. I will ask Tanisha, can you hear me now? Are you able to unmute?
Yeah. Can you hear me?
Yeah. So can you tell me the IUPAC name of the first?
Okay. 1, 2, 3, 4, 5. Pentane.
Pentane. Very good. Can you try second?
Yeah. 1, 2, 3, 4. 2-methyl butane.
Very good. Third one.
Okay. 1, 2, 3, 4. 2-methyl butane.
Yes. It is also 2-methyl butane. If both are 2-methyl butane, then they are not two different structures. They are same substances. Therefore, you have to consider them as one only. Okay, they both are same. So, last one will be, we have written now 2,2-dimethyl propane. So now you observe it has no four compounds. It is having only three isomers. Three chain isomers. Pentane, 2-methyl-butane, 2,2-dimethyl propane. Root word you see, pent, but, prop. So remember, if they give you two different structures, but when you write the names and the names are same, then both of them are same substances. You should not consider them as different things. Hmm? So here three chain isomers are possible for C5H12. So common names we should know for these. Again straight chain के लिए N pentane. If there is one branch, you will call it as isopentane. And two branches are there, we call it as a neopentane. ठीक है? N-pentane, isopentane, neopentane. Any doubts how to write? There will be one question definitely. Okay. So these two are examples of chain isomers. So chain isomers, easy way to identify is that the root word will be different. If they give you simply pentane and 2-methyl butane are examples of dash isomers, then chain isomers, their root words are different. No? But the second one is position isomers. Means here the position of the double bond or a triple bond will be there. Different. So it will be usually for alkenes, alkynes, or sometimes alcohols also, because alcohols also have different position of the functional group. So common examples they will give you here is but 1-ene, but 2-ene. So you observe here what is common. Everything is common except the position of the double bond. Here it is 1, here it is 2. So when you write CH3, CH double bond CH, CH3. This is but 1-ene. Sorry, 2-ene. So this one CH, CH2, CH3. So this is but 1-ene, this is but 2-ene. So everything is same, only the position of the double bond here is different. So since the position is different, we call it as a position isomers. Same thing for alkyne, but 1-ine, but 2-ine. Alcohols के लिए we have seen the pent, butane or prop. So which is more than 3 or more than 3. This one, this one. This is 1-propanol or propan-1-ol. This is 2-propanol or propan-2-ol. So position of the alcohol is different. ठीक है? Okay. So now if they give you names, how to write the structure? So let's take the previous year questions. See, they have asked us to draw the structural formula for each of the following. Ethanoic acid, but2YNE. तो we know ethanoic acid मतलब carboxylic acid. Carboxylic acid में COH group should be there, right? So eth, again what you know from that information only have to write. Eth, eth मतलब 2 carbons. In the 2 carbons, one should go with COOH here. And what is left? Only 1 carbon. So to that required number of hydrogen you give. So this is your ethanoic acid. Ethanoic acid is nothing but acetic acid. So this will be how you will write the structural formulas. But2-ine, YNE. So Dhruva, tell me how you will write. Dhruva, Chanvi, second one, butadiene, but, hmm, triple bond between second and third carbon, no? Okay. Then, so then make sure that every carbon has four bonds. So if you observe here, this carbon already has four bonds. This carbon also already has four bonds. So this will be the structure. Okay. So same thing. See, these are all previous year questions. Simple structures only they have asked. Methanoic acid. The first member of carboxylic acid. Meth matlab only one carbon you have to write. So that carbon will go to what? COOH. And how many bonds it has to need? One more. So that you write only H. So it will be HCOH is a methanoic acid or formic acid. See here, ethanol. Nal means aldehyde. Eth means two carbon. So two carbon में one carbon will go to aldehyde group. Aldehyde is simply C double bond O H. Okay. And remaining carbon के लिए you have to write three hydrogens. Ethine. Eth means two carbons. Ine means triple bond. So that should be between these two only. So it requires one more bond that is given by hydrogen, right? 2-methyl propane. Prop means three carbons. Ane means all are single bonds. Second position में methyl group. So methyl के लिए also you have to expand it like this. Don't write CH3. You have to expand that. If you don't expand, then no marks. Okay. One second. Yeah. Okay. So I was telling 2-methyl propane के लिए prop three carbons. Second position methyl group. So methyl group के लिए you have to expand. So that one. Give the structural formula for, see here, instead of asking you directly, they have asked an isomer of n-butane. So what is the isomer of n-butane? It is isobutane, है ना? Don't write for n-butane. N-butane का isomer is isobutane. Isobutane is where you will write four carbons, but one carbon will be as a branch. So again, it is 2-methyl propane only, whatever we have written above. Okay? Neobutane will not be there. Only N and iso. Neo is not possible. Only two isomers. 2 propanol. So this 2 is telling you the position of the alcohol group. So prop means three carbons you have to write. Second may you have alcohol to write OH. O and H also you expand. Then write required number of bonds like this. ठीक है ना? So this is how we have to keep practicing. But let's take 1,2-dichloroethane. 1,2-dichloroethane. Wait. Iona, can you tell the structure, how to write it? I can't hear you. Huh. Little louder, yeah.
Because you draw two carbon,
Hmm. Two carbon.
and on the carbon you one on one of the carbons you draw an OH.
What we have to draw?
OH.
1 to dichloroethane we are drawing.
Oh,
Uh,
then on each of the carbons, one fluorine.
Okay. And remaining?
Hydrogen.
Right. Simple. So 1 to dichloroethane. Okay. Write the IUPAC names of each of the following. First one. Chanvi, tell me the answer.
Yeah, sure. One, two, three. There's three, and then there's a bond. So that's double bond, right?
Yeah, double bond.
So proptoane. No, proptoane.
This this is here. One position you have to write.
Oh,
It is starting at the position one, na?
yeah,
You have to
yeah.
run number in such a way it should get least possible
Oh,
number.
yeah. The propone.
One
Okay.
propene or one propene you can write or simply propene also fine.
Oh, I forgot the words.
Hmm.
Mm.
ठीक है. Ruhani, tell me the second one.
Yes.
It's a triple bond here, okay?
Okay. Yeah. So Puge to iron.
Very good. So Darshwana, third one.
Sir, uh, ethanol, 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 yeah.
Ethanol, Al, because this group is aldehyde, so we have to use Al. Okay. 2,2-dimethyl butane. Okay. Dhanesh, can you tell me the first one?
So it will be one carbon, so it will be methane, methanol acid.
Method?
Methanol, no, it's a aldehyde, so I forgot the name. It's al, yeah, methanol.
Methanol. Okay, fine. Isha, can you try the second one?
Yeah. Uh,
Three carbons are there, one OH group is there.
yeah. One,
Three carbon means what is the root word?
pro.
Yeah.
So is it one hydroxyl?
Hydroxyl Y.
This
Secondary
is
suffix के लिए OL you use ना?
uh,
It will
so
not be as a substituent. हाँ.
uh, propanol.
Propanol. Single bonds, so AN. OL is for secondary suffix. So you can write propanol or one propanol or propan one ol. ठीक है. So here if you observe, they have asked write the structural formula of the two isomers of butane directly. So that is N-butane and isobutane. है ना? So that we have to draw. ठीक है. So this is all about writing the structures and writing the names. Hmm? So if you didn't get it, once again, if you want, I will upload the recorded session. You can go and watch it.
Neopentane. So neo does not exist for butane, right?
Butane has only two isomers only possible, N and iso.
And neopentane is just two branches, right?
Hmm. Neopentane to remember like plus mark. Okay. So it will have one straight line with three carbons and one above and one below methyl groups. ठीक है. चलो. Let's see how much we are able to take. So if your basics now you got correct, then we can take the alkenes. So here mainly you have to focus on what are the methods of preparation of alkenes and what are the properties. Simple things are there. Two methods are there to prepare it, and chemical reactions will be oxidation as well. Oxidation means combustion and substitution. Okay. All the naming, isomerism, all we have learned for all the things. So we will take which of the following statements is wrong about alkanes. So read it and tell me which one will be wrong.
Sir, is it the second one?
Right. So they can undergo addition as well as substitution. No, they can undergo only substitution and not addition. Okay. Organic weak acid. This is from your acid basis salts. Yeah.
Sir, I didn't understand a non-polar and polar.
Non-polar matlab if it is having the same electronegativity elements. Okay. So H
Like
and
yours.
H. Here all the organic compounds, they are made up of carbon and hydrogen, so they have almost same electronegativity. So they will be non-polar unless if there is oxygen coming and attaching. Like carboxylic acid is polar, alcohol is polar. Okay, but only carbon, hydrogen, all the alkane, alkene, alkynes, they will all be non-polar. Okay, the organic weak acid, so that will be formic acid. Unsaturated hydrocarbons undergo again addition reaction. This any one question will be there. Huh? Don't do mistakes in this. IUPAC name of acetylene. Okay, acetylene is the first member of alkyne. The first member of alkyne is ethine. So common name for ethine is acetylene. Iona, can you mute please? And ethene common name will be ethylene. So these common names we need to know. इथाइन के लिए acetylene, ethene के लिए ethylene. Methane structure is this. Anyway, it is a commonly called as marsh gas because it is evolved in the marshy lands. Also, it's a greenhouse gas. Okay, greenhouse gas is methane. So in alkanes, we are learning only about methane and ethane, not about higher members. So methane is the greenhouse gas, not ethane. Okay, so this one again, methane. Let's come to preparation part, important things. So here we have two methods of preparation, so where depends upon what reagent we are using. So if you see here, first one, we are using soda lime, so that reaction we call as decarboxylation reaction. Decarboxylation reaction. Why it is called decarboxylation? D matlab removal, carboxyl matlab COO group. Okay, we are removing COO group. It may be gone as a CO2 or as a carbonate, doesn't matter. Okay, if you are removing the carboxyl group, that will be called as decarboxylation reaction. So to do decarboxylation reaction, we use soda lime as a reagent. So in organic chemistry, you have to remember based on the reagent. A particular reagent will do a particular work in organic chemistry. So soda lime means always it removes the COO from the other substance. Okay. So soda lime is what? It is a mixture. Soda comes from caustic soda. Caustic soda is NaOH. Lime comes from quicklime. Quicklime is what? Calcium oxide. So it is a mixture of these two. Why we prefer it? Because it is not deliquescent, whereas if you simply take NaOH, it is deliquescent. What is the role of CaO here? It has no role in the reaction, but it will make sure that NaOH does not uh, absorb water, because CaO, quicklime, is a drying agent now, so it will make sure this will not take the water. Now come to reaction part. To get the methane, we have to take sodium acetate. So how we got sodium acetate? Acetic acid we know. Acid base reaction you have to do. Normal acid base reaction give you what? Salt and water, है ना? So in place of this is anion. Okay, I will write here HCl. Reverse I have written. ClH is what? HCl only, no? So when HCl react with NaOH, what you will get? NaCl. So Cl I will write first here. H2. So imagine in place of Cl you have CH3COO minus, which you call as acetate ion. CH3COO minus. So that CH3COO will go with Na. You will get sodium acetate. But here only difference here is acetate. Anion we are writing first. Then the cation. Understood now? Otherwise, if you remember sodium acetate as it is, no problem. If you don't remember what is sodium acetate, then this is how we get it from acid-base reaction of these things. So to this, we are adding again soda lime. Soda lime may you have to write sodium hydroxide in the reaction part, quick lime on the arrow mark. So temperature 300 degrees Celsius we have to write. So here what happens? You are getting the methane. This is CH4 and this H you have to remove. What it will become? CH4. What is left? Sodium 2 are there, Na2. One carbon is there. How many oxygens are there? 3. Na2CO3, sodium carbonate. Now you observe COO is going out as a carbonate. Therefore the name decarboxylation. Now what you got? Methane. It's a gas. Okay. I want to get ethane. Only first two members we have to worry. Ethane and methane में difference is how much? CH2 group. है ना? CH2. The difference here is CH2. That CH2 you have to give to sodium acetate. It becomes what? CH3 COONA. This is sodium acetate. Now in between you give one CH2. You can write like this, or you can club these two together and write C2H5COONA. This is what? If there are two carbons, this is acetate is a common name. Okay, ethanoate we call it. Two carbon के लिए eth. IUPAC name will be sodium ethanoate. CH3COO minus ethanoate ion. So similarly here this one will be called as sodium propanoate. 3 carbons. 2 carbons here, 1 carbon from COO group. So to this same thing we are adding NaOH, baki sab same. CaO 300 degrees Celsius. You are getting C2H6 plus drying, not dehydrating, drying.
Why do we use CaO apart from drying? Is there another reason?
No need. It is just make sure
For it to be non-dehydrated or something like that?
soda lime, it will keep it dry. Okay. When you simply take sodium hydroxide, it will absorb the water. So it will affect our reaction. To keep it away from the water, we are adding calcium oxide. It's a mixture of these two. But which one reacts with this? Only NaOH. Calcium has no role in the reaction. Therefore, you have to write it on the arrow mark, not in the reactant or product side. Okay. So these two are the reactions to prepare methane and ethane using soda lime. What is starting material take? Sodium acetate or sodium ethanoate. And to get ethane, you will use sodium propanoate. You have to practice. These reactions are simple if you understand what is the role of this, how the Na2CO3 is formed. Huh? This is one method. Second method, we use the reagent reduction method where you use zinc copper couple in alcohol. Zinc copper couple. See, it is nothing but they will take granulated zinc. Granulated zinc, है ना? उसके ऊपर they will sprinkle the copper powder on top of it, and that they will add to alcohol. So this mixture will give us something called as nascent hydrogen. We write it like this. Nascent hydrogen. Nascent hydrogens are more reactive than hydrogen gas. because they are in atomic state now, so they are not much stable, so they will react with uh, other things very fast compared to hydrogen gas. So here second method may we prepare alkane, sorry, this one, alkanes, methane and ethane from their iodides or halides, alkyl halides से. Methyl iodide say methane, ethyl iodide say ethane, like that. Okay. So here you have to write two nascent hydrogens for this reaction. Iodomethane, how you convert iodomethane to methane? Okay. So always you have to think in this way. What are the methods to prepare methane? Two methods, soda lime or zinc copper couple. तो सोडा लाइम के लिए you have to use sodium acetate. तो then it should be second method. Iodomethane से methane you want to get मतलब second method, where you will use zinc copper couple in alcohol. Okay. See, reaction when an alkyl halide is treated. Okay, this one will be in the second part. A mixture of soda lime and sodium acetate is heated. So what we get? Sodium acetate is CH3COONA plus soda lime is NaOH. On the arrow CaO heated, you will get CH4 plus Na2CO3. Okay. Triple. Okay, this one you can do. You know. Coming to chemical properties, only two properties. One, combustion means when you burn methane and ethane, what you are getting. So all the hydrocarbons, not only methane, ethane, alkane, alkene, alkyne, alcohols, all of them when they undergo complete combustion, means complete in excess amount of oxygen, you will always get CO2 and water. But in only certain cases where the oxygen is not sufficiently available, limited supply of air, then we get carbon monoxide instead of carbon dioxide. Carbon monoxide is a poisonous gas, especially like in traffics. So large number of vehicles are there, all are on only, but little bit space. So what happens? Availability of the oxygen from the air will be less. In such cases, carbon monoxide will be released. Or in the kitchen, if there is no proper ventilation, then also all the oxygen is utilized. Matlab slowly, instead of forming CO2, it starts forming CO. So remember, complete combustion may all things will give you CO2 and water. But incomplete combustion may carbon monoxide will be formed. It is dangerous to burn methane in an insufficient supply of air. Again, same thing, because it gives CO, carbon monoxide, which is poisonous. So poisonous matlab what it does, it will combine with the hemoglobin and supply of oxygen will be cut off. Second one is the substitution. Substitution reaction is very simple. But what you people do mistakes, if they ask you preparation method, you use substitution. If they ask you substitution method, you go to preparation. Simple thing, simple technique is whenever they give methane or ethane on the product side, then you have to think only about the preparation method. Okay. But whenever they give you methane and ethane on the reactant side, then you have to think about the chemical reactions of methane and ethane, because what they are undergoing. So here simple thing, already alkanes are stable. They don't want to go undergo any kind of reaction. But we make them undergo reaction in presence of diffused sunlight. Means we are giving them energy so that they can become unstable. Okay. So CH4. CH4 में this H is replaced by the halogen. Halogens may be chlorine, bromine or iodine. We don't use fluorine. Okay, the reaction is explosive in nature, so we don't use it. So this, what we are adding, chlorine gas. in presence of diffuser sunlight. You have to write this condition. If you don't write the condition, then it is incorrect. So H is replaced by Cl. So what is going to happen here? Cl. That H will go with combine with another Cl. So your byproduct will be hydrogen chloride, not hydrochloric acid. No? So what you are getting here, H is replaced or substituted by the chlorine. So you are getting a chloromethane. You know, but still there are three more hydrogens which can be replaced. So in each and every step, one hydrogen is replaced. Second case में this will be gone. Third step में this will be gone. Fourth step में this will be gone. So you will be in getting dichloro, trichloro, tetrachloromethane. Your byproducts will be HCl only. Okay. Here you should know the common name for trichloromethane, which is called as chloroform. Because sometimes they have asked how you prepare chloroform from chloromethane. Chloromethane is CH3Cl. Chloroform is CHCl3. Okay, so 2 chlorine we have to add, or you can write 2 steps, or 2 chlorine with 2 HCl, or 2 steps also you can write, not a problem. Okay, so chloroform and carbon tetrachloride anyway you know. Same thing happens for the ethane also. So ethane has 6 hydrogens, so all of them will be replaced. Uses part में methane and ethane will be used as fuels mainly. So this is the same reaction for ethane. You can see C2H5COONA using soda lime. Remove the sodium carbonate. So write this on the arrow mark. Okay. And second method is reduction using zinc copper couple. This also we have to write on the arrow. Conditions. Alcohol. Okay. Nascent hydrogen. Here don't write the hydrogen gas. Functional group of methanol. Okay, let's see the reason here. Methane does not undergo addition reaction, but ethene does. So we have to explain methane is saturated, it is already stable. Ethene is unsaturated. It undergoes addition reaction. Okay, because of high reactivity. Ethine is more reactive than ethane. Same thing you have to explain. Hydrocarbons are excellent fuels. So if they ask you this particular question, write that hydrocarbons have high calorific value. What is the calorific value is when you burn 1 mole of any fuel, how much energy it is releasing. So they have very high calorific value. Physical properties में ठीक है. Alkynes general formula. Same chemical properties of ethane is also same. When it burns in presence of oxygen, CO2 plus H2O. Incomplete combustion के लिए और limited supply of oxygen में we get carbon monoxide. Okay, equation for complete combustion. So I will tell you one trick to balance these kind of reactions. I told you in regular classes, whoever knew. See, complete combustion के लिए we should know first of all, it will give us CO2 and H2O. What you do, first balance carbon and hydrogen. Oxygen you keep last. Carbon is 2 here. You know, oxygen, hydrogen are 6, so make it 6. Okay, now you see how many oxygens are on the right hand side. 2 into 2, 4 plus 3, 7. So you can't make it 7 on the left hand side. What you can do, you can take 7 by 2. Okay. So to remove this 2, what do you do? Multiply this whole equation by 2. Now what you will get? 2C2H6 plus 7O2 gives you 4CO2 plus 6H2O. So this is how you can easily balance such questions. Okay, again substitution reaction condition is what? Diffused sunlight. Okay, so you can see here 6 steps are there for ethane because there are 6 hydrogens. One hydrogen you want to replace, one step. So 6 steps for 6 hydrogens. So in each and every step, chloroethane, dichloroethane, trichloroethane, tetrachloro, pentachloro, hexachloroethane. C2Cl6 what? Hexachloroethane. Okay. Here they didn't give a structural formula to write now where the chlorine positions. You want to write 1, 1, 2, 2. We don't know the structures here, no? So you can simply write hexachloroethane, pentachloroethane like this. If they specifically give structures, then we can write it. Okay. Janvi, tell me the answer for this.
Sure.
Yeah.
For this, it's substitution.
Yeah. This is substitution. Okay. Where the hydrogen of an alkane is replaced by the halogen. Do not consider it as halogenation. Okay, in alkanes you don't have halogenation, nothing. Halogenation, chlorination, bromination will be only for alkenes and alkynes. Hmm? Okay, so this is the kind of questions they have asked previously. So name the organic compound prepared. So here we C2H5 and 1, है C2H5 के लिए you will get C2H6, ethane you will get. So here methyl is there, methane you will get. So organic compounds prepared are ethane and methane, names you have to write. Distinguish between saturated unsaturated, drawing the structural formula. ठीक है, ethane and ethane structural formula you can write here, है ना? Addition reaction, substitution reaction, which type of organic compound? Okay, ethane undergoes substitution because it is saturated. This one undergoes addition. Uses mainly we will see on alkenes and alkynes. All same kind of questions, general formulas. Chemical equation they have asked, so you have to practice. Couple of equations are there. No? Give the IUPAC name of the isomer C4H10 which has a branched chain. The branched chain is the one which is called as isobutane. 4 carbons, na? So isobutane ka IUPAC name they have asked. So that will be 2-methyl propane. If you write the structure, it will be CH3, CH, CH3, here one branch. Okay, this file I will upload. You can go through this naming and all. If you don't get anything, let me. Let's start with alkenes and alkynes. We learn them together because lots of similarities are there in them. So straight away, if you take before you take this one, I would like to tell you something. Alkanes, commonly called as paraffins. Okay, why this common name it has? Because it is made up of two words, param and affinis. Param and affinis. Param means little. Affinis means affinity. Since we know alkanes, they are saturated hydrocarbons. Saturated hydrocarbons are stable, means less reactive. Little affinity is nothing but they are less reactive. Okay. Talking about the alkenes. Alkenes commonly called as olefins. Olefins meaning oil forming. Okay, it is used in making oil. Alkynes we don't have any common name. Coming to the preparation method, the first member of alkene is ethene, which is commonly called as ethylene. General formula we know CnH2n minus 2, right? And for acetylene, it is CnH2n plus 2. I mean for alkynes. The first member of alkyne is acetylene, common name ethine. Ethine is a IUPAC. So as I told you yesterday, for alkenes and alkynes, the first member starts with N is equal to 2. The reason, at least one carbon to carbon double bond. Matlab there should be 2 carbons at least. There is no methene or there is no methine. Okay. So here again same thing. First, we will see the method of preparation. For both of them, one method is common and one method is unique. So first, let's see unique method for preparation of ethene. This one we have learnt in H2SO4 chapter. You know? So dehydration of ethanol, where we use concentrated sulfuric acid as a dehydrating agent. So you have to write the equation this one. So when dehydration of ethanol takes place, we will get ethene and water. So for your understanding, I will explain it here how it happens. Okay. So you are taking ethanol. Yesterday we have learned how to write the structures like this. We are adding concentrated sulfuric acid. Whenever concentrated sulfuric acid acting as a dehydrating agent, you have to write it on the arrow mark. Temperature is 170 degrees Celsius. So what it does, it takes away hydrogen from here, OH from here. H2O is gone. H2O is gone. Now if you remove, so OH and H, this carbon needs one more bond, this carbon also needs one more bond. So they will form a double bond between themselves like this. So what is your product? Ethene. Okay? So this is called as dehydration. We can also use another reagent or a dehydrating agent, which is aluminum oxide. But temperature is around 360 degrees Celsius we have to keep. Okay. Coming to unique method for the preparation of ethyne or the acetylene, first member of alkyne, calcium carbide with water will give you respective hydroxide, that is calcium hydroxide plus ethyne. Now what is calcium carbide structure? Carbide is this. It is actually a anion C2 minus 2, and it has a ionic bond with calcium ion. Okay, so when you write it together, CaC2, water will hydrolyze this, means it will break this compound. Water, what happens? HOH, HOH, means OH part of the water is going with calcium, H part is going with C2. So what you are getting here, right hand side, C2H2, and here calcium hydroxide. Okay, so this is another unique method to prepare ethine. See here, they have asked give balanced chemical equation for the following conversions. Ethanoic acid to ethanoate, we will see next. Calcium carbide to ethine, just now we have seen. Sodium ethanoate to methane. So if you remember, yesterday we have learned which reagent we use here to convert sodium ethanoate into methane. Anybody? Soda lime. Yes. The formula you have to write only NaOH here, calcium oxide and the arrow. Okay, 300 degrees Celsius, you know, plus sodium carbonate will be the byproduct. So second method of preparation, which is common for both, that method we call as dehydrohalogenation. Dehydrohalogenation. So understand what is this dehydrohalogenation. D means removal, hydro water, halogen ClBr or I, okay, or chloride, bromide, iodide is going on. So here to carry out the dehydrohalogenation, we need a reagent. So what reagent we use here? Alcoholic potassium hydroxide solution. Remember, in alcohol preparation, next part, we use same potassium hydroxide but in water. There you have to write aqueous potassium hydroxide, but here you have to mention alcoholic potassium hydroxide. ठीक है? So हाँ,
aqueous
Next
potassium
part,
hydroxide.
alcohol
Okay.
preparation we will see.
Yeah.
Okay. So here ethene is prepared by dehydrohalogenation of ethyl chloride. So you have to take alkyl, especially not only alkyl, here you are preparing ethene, matlab you have to take ethyl. Ethyl chloride is what? It's a common name for chloroethane. So we need to know some common names. In general, I will try to help you that haloalkanes, haloalkanes, that is IUPAC name, will be called as alkyl halides commonly. For example, if I take halo means say here chloro, alkane means I will take methane. So chloromethane is a IUPAC name and its common name will be methyl chloride. Okay. Same way, say for example, they have given here iodoethane. Common name will be ethyl iodide. So whatever iodo, you make it iodide. Whatever ethane, you make it ethyl. So if you remember this one, then it will be easy for you. Because we never know whether they will give you IUPAC name or common names to write the equation. Okay, therefore, so here ethyl chloride we can use C2H5Cl. In place of Cl, there can be Br also or iodine also. Ethyl bromide, ethyl iodide. To this, we have to add potassium hydroxide in alcoholic. So you have to mention alcoholic. Okay. And this requires heating. So write heating
So,
symbol. Yes.
where do we use aqueous KOH?
To prepare alcohol. Next, we'll see. So here what happens? This potassium will take away the Cl. So potassium chloride is gone. Then this OH, what this will do? It will take away out of 5 hydrogen, any one hydrogen it will take away. So OH plus H will be H2O. Then what is left here if one H is gone? C2H4. C2H4. This is nothing but your ethene. Okay. So this is how you can try to remember if you want. Here, see. This is ClHHH ethyl chloride. Now bring the potassium hydroxide. I will write it like this. Take the potassium with Cl. Okay. Then take H with OH. Then Cl is gone, H is gone. This both of the carbons require one bond. So they will form a double bond between themselves. C double bond C H H. Okay. Plus KCl plus H2O. So always potassium will take away the halogen. Since halogen is gone, water is gone, this method is known as dehydrohalogenation. Okay. So same reaction we do for preparing ethine as well. But in to prepare ethine, you need to have two bromine atoms. Means two halogens should be there in the molecule. So it should be 1,2-dibromoethane. The two bromine should not be on the same carbon. They should be on two different carbons. Okay, see here. One bromine should be here, another bromine should be here. If it is on the same thing, then it will not work. Okay. We commonly call this as ethylene dibromide. Common name is ethylene dibromide. IUPAC name is 1,2 dibromoethane. Again, same reagent we use here, potassium hydroxide. Which one? Alcoholic. But here you need to remove two bromine atoms now. So you need to know get two potassium hydroxide. Okay. So you will get two potassium bromide. Two potassium will take two bromine. Two OH will take two hydrogens. So two H2O. So two hydrogen is gone. Two bromines are gone. What is left? Two carbons and two hydrogens are left, which is C2H2. which is ethane. ठीक है? So this is your second reaction to prepare ethane. So both are use same reagent. If you don't write alcoholic, you write everything, you don't write alcoholic below KOH, then it is wrong. Okay. Preparation of methane from iodomethane. So preparation of methane from alkanes. Okay, what reagent we use here? There are two methods to prepare methane. One is using soda lime, decarboxylation. Another one is what?
So with using with that zinc copper couple. Zinc copper couple.
Right. So we call it as a reduction zinc copper couple in alcohol. So that will provide nascent hydrogens, two nascent hydrogens. One hydrogen will go with CH3, it becomes CH4. Another hydrogen will go with I, so it becomes HI, hydrogen iodide. See, remember this alkyl here methyl iodide, they can change it to methyl chloride, methyl bromide. But don't worry about that part. Remaining you should know. The property by virtue of which the compound has same molecular formula, different structural formula. The Dhruva, tell me what is the answer for this? Dhruva? Yeah. Isomerism, yes. Do not write isomers. It is property they have asked. If they write the compounds, then it is isomers. Give a balanced equation. Again, see, I have included that so that it can get revised. Sodium propanoate say how you get ethane. So you want to prepare ethane. Matlab you have to think about the methods of preparation of ethane. Again, two methods. Soda lime, another one is zinc copper couple. So here we will use soda lime where sodium is there in the starting material. Sodium propanoate. Propanoate के लिए you have to take C2H5 COONA है ना, plus soda lime is NaOH, calcium oxide, byproduct is sodium carbonate. Action of alcoholic potassium hydroxide on bromoethane. Now see here IUPAC name they have given. Bromoethane you should know how to write. है ना, C2H5Br plus KOH alcoholic dehydrohalogenation. KBr is gone. If only one bromine is there, then it is giving you ethene. If it is C2H4Br2, then you will get ethine plus C2H4. Okay. So all these, whatever we learned, methane, ethane, ethene, ethine, all of them are gases and insoluble in water. So what we do, all of them we collect by the same method of collection. Okay, rarely they may ask you which method of collection we use to collect these gases. So all of them are collected by downward displacement of water because they are not soluble in water. Just like hydrogen gas we collect, oxygen gas we collect, same. Physical properties में ठीक है. These two will have lightly some smell. So here pleasant odor for ethene. This one is also having sweet smell, but all these gases are colorless gases. Okay. The organic compound containing COOH functional group. So you can just write the general name carboxylic acid. Coming to chemical properties, in alkanes we have studied two chemical reactions. One is combustion with oxygen. So same thing happens here also. When there is a complete combustion, products will be CO2 and water, and all the combustion reactions are exothermic. So plus heat will be there. Okay. Another reaction for alkanes, what we studied, they are saturated, so they will undergo substitution. You know? So each hydrogen is replaced by halogen. Okay. But here, these reactions will undergo addition reactions. Addition reactions. So whenever there is a double bond or a triple bond, so across that double or triple bond, other molecules can come and add, and they become saturated after the reaction. So such reactions are addition reactions. So here see, these are all single bonds. So this is what ethene. Okay, now we are learning the chemical reactions. Ethene you can write like this or horizontal also, doesn't matter. They wanted to show that they are going to add across the double bond, so they have written like this. Okay, so Cl you can write like this. Hmm? So once the reaction happens, carbon and Cl will form a bond. This carbon and this Cl will form a bond. So now carbon cannot have 5 bonds. Already it is 4 bonds it has, but it is again forming extra bond. You know? So what it does, one of the double bonds it will break. It becomes a single bond. Then between chlorine and chlorine, that bond also will be broken. That also will become separated. Now Cl will go and attach to this CH2. This Cl will go and attach to this CH2. So now what you are getting? CH2Cl, CH2Cl. So remember, both the chlorines are not going on the same carbon. They will go to two different carbon atoms. So your products will be 1, 2 dichloroethane. Right? Same thing happens for bromine, addition of bromine. Right? So both the bromines will go and attach to each carbon and you will get 1, 2 dibromoethane. Here condition you remember, for chlorine and bromine addition, we use a solvent which is CCl4, carbon tetrachloride, which is liquid actually at room temperature. Hmm? So this one we use here, solvent, carbon tetrachloride. But for addition of hydrogen, we need some catalysts. So the catalyst we can use here is nickel, platinum, or palladium. Any one, temperature 300 degrees Celsius. Okay. So hydrogen will go and add across the double bond, so it becomes single bond. So here it becomes ethane. How do you convert ethene into ethane? So you have to do addition of hydrogen. So these have names. Addition of chlorine will be called as chlorination. In general, halogenation. This one is known as bromination. But for addition of hydrogen के लिए we call it as a catalytic hydrogenation. Catalytic hydrogenation, because we require a catalyst here. But in first two cases you have to write inert solvent, that is CCl4 should be written. Why you have to think why? Because here C2H2 is a gas, Cl2 is also a gas, and they want some liquid where the both of the gases can dissolve and react with each other. So that will be an organic solvent as it is not soluble in water. Now, therefore we use CCl4. Instead of Cl4, you can use CBr4 also, carbon tetrabromide. Hmm? So in some cases, if they give you carbon tetrabromide, it is same inert solvent only. Okay, same thing we do for ethyne addition, addition reactions of ethyne. But here, since there is a triple bond, so if you add only one chlorine, it becomes a 1,2-dichloroethene. Only one bond will be broken between carbon and carbon. So it will become a double bond. But you have to add one more chlorine because ethene also undergoes chlorination. So you will get final product 1, 1, 2, 2. Tetrachloro. Final product will be alkane only, ethane. Okay. Again, the condition you have to write CCl4. So what अगेन हियर इथाइन के लिए टू molecules, 2 moles of chlorine, 2 moles of bromine, okay, and 2 moles of hydrogen. If you take only 1 mole of hydrogen, ethine will become ethene. Then to ethene again addition of hydrogen will give you ethane. But if they simply ask you for 1 mark, how do you convert ethine to ethane? So what do you do? C2H2 plus 2 moles of hydrogen, C2H6. These addition reactions are easy to write. There's nothing to balance. C2H4, ethene. You are adding bromine in CCl4. You can write here or on the arrow. C2H4Br2. Just add them together. Okay, that's it. Same for chlorination. Huh. Here, this particular reaction is there, na, bromination. This reaction we use to distinguish between saturated and unsaturated hydrocarbons. Why? Because in this particular case, bromine, what we use? Bromine in CCl4, or sometimes they use bromine water, means bromine dissolved in water. It
Sir,
is
is it mainly nickel only?
it is mainly
Nickel.
what nickel? Huh? You are talking about the second one. Okay. So here reddish brown in color. This bromine in water is reddish brown in color. Once it undergoes addition reaction, it can undergo addition reaction only if there is alkene or alkyne. So that bromine will go and add across a double bond or a triple bond. So what happens? This decolorization happens. Decolorization of bromine water, which is reddish brown in color, becomes colorless. Why? Because it is undergoing addition reaction. Whereas if you take this bromine water and add it to alkane, there will be no decolorization. The reason is alkanes do not undergo addition reaction, right? But you may think, sir, but we have seen yesterday substitution reaction, na? CH4 I will take, bromine I will add. So it is undergoing reaction, correct? But conditions what you are taking. Here you are taking bromine water or bromine in CCl4. But for alkane substitution के लिए you have to take pure bromine under diffused sunlight. You are not using any solvent there, correct? Then the substitution reaction take place. This is different, okay, and this is different. Understand this. Conditions are totally different. Hence, alkanes will not decolorize the bromine water, whereas alkene and alkyne will decolorize it. What is the reaction? Simple addition reaction only. Okay. Darshvana, can you answer this question?
Yes, sir. This will be substitution.
Ethene can undergo substitution? Can it?
No, sorry. Addition, sir. I learned it as ethane.
Okay. So ethene, if it is there, addition, ethene, ethyne, etc. Okay. Rishi, can you answer this question?
Yes, sir. Conversion of ethane to ethane hydrogenation.
Hydrogenation. Yes. Okay. Chanvi, tell me the answer for the first one.
The catalyst used to make so what ethine to ethane. So alcoholic fluid.
Catalyst.
So I don't know.
C2H2 say C2, what is this? Ethane, na? C2H6. What you will do? You add hydrogen. Hydrogenation. Hydrogenation के लिए which catalyst you use?
Yeah.
Which
Okay.
catalyst?
nickel.
Huh. That you have to write. है
Okay.
ना? What else? Platinum or palladium? Anyone you can write.
Okay.
The type of reaction alkenes undergo, again, it is addition reaction. Okay. Dhanesh, can you answer this question? What is A? You can tell me what is A.
Yes, sir. Um, so this it's a
What is A? Name.
it's alkyl.
Specifically which one?
C2 H6.
C2H6 is alkane, no?
Sorry. C2H4.
C2H4 is what?
Um, E ethene.
Hmm. First member of alkene, ethene, है ना? तो इसका structural formula we have to write. Okay, state your observation during this reaction. Reddish brown color of Br2CCl4 gets decolorized. This is what you have to write. Uses part: ethene mainly used in artificial ripening of the fruits. Ethine, remember, oxyacetylene flame for welding purposes. Okay. Oxyethylene flame is also there, but I don't want you to get confused. Here, this is also used for artificial ripening of fruits. But remember, artificial ripening के लिए ethene, for cutting and welding using oxyacetylene flame, that is ethine. Okay, because oxyacetylene flame, they give very high temperature which is able to melt the metals, so we are able to cut and weld them. Okay, so this is how you can distinguish. Now we know how to distinguish between saturated unsaturated, है ना? Alkanes versus alkene or alkanes versus alkyne using bromine in CCl4 or bromine water. This one is used to differentiate between alkene and alkyne because both are unsaturated. Bromine you can't use here because both undergo addition. So we use some other reagents. No need to remember the equation. You need to know the solution what we are using. Ammonical silver nitrate solution or ammonical copper 1 chloride, that is cuprous chloride solution. So in both the cases alkenes no reaction, or you can simply write no reaction or no precipitate, you can write for both the cases. But for silver nitrate solution, that too ammonical, means you have taken silver nitrate and added some ammonia solution, made it a slightly alkaline in nature. So such thing when it reacts, usually silver compounds will give you white precipitate, you know. So if there is an alkyne, it gives us white precipitate. Whereas similarly, ammonical cuprous chloride. So this will give us red precipitate with alkyne and no precipitate with alkene. So this is the one which we use to differentiate between, distinguish between alkene and alkyne. ठीक है? Okay. Aryan, can you read and tell the answer?
Yes, sir. Can you hear me?
Yes.
An organic compound undergoes addition reaction and gives a red color precipitate with ammoniacal cuprous chloride. Therefore, the organic compound could be uh, ethine.
Yes. Right. So only alkynes will show this. Write a balanced chemical equation. Burning of ethane in plentiful supply of air. So here, what will be the products? Ruhani, what will be the products? Hmm.
and water.
Hmm. Okay. So, and all combustion reactions are exothermic. Yesterday, I told you people how to balance this. First, balance carbon and hydrogen, then oxygen. You know? So, here, I think 2 here, 3 here, 7 you are getting. So, multiply by 2, right? How much we are getting? 7, 4, 2,
Six,
3.
six.
So, this. Okay. Second one, action of water on calcium carbide. So calcium carbide is CaC2H2O. So hydrolysis breaks the calcium carbide into calcium hydroxide and ethane gas will be released here. Heating ethanol at 170 degrees Celsius in presence of Kong sulfuric acid, dehydration. Ethanol you
So
can write. Hmm.
C2H5OH.
Hmm. Conc H2SO4 you should write on the arrow 170 degrees Celsius also we have to write. Just remove the H2O from this. So what is
So
left after that? C2H4. Yeah.
will they ask the preparation of calcium carbide?
No, that will not. Okay.
Because there's one more reaction in our book
What
not
is it?
showing.
Hmm. What is
Not
it?
showing the preparation of calcium carbide.
How it is prepared? What they have given?
So 1 second.
Hmm.
I'll tell you, so you continue.
Hmm. Name the process by which ethane is obtained from ethene. So Isha, can you answer this question?
Um, catalytic hydrogenation.
Very good. Catalytic hydrogenation. Right. Tanisha, second one.
Methane.
Methane. Greenhouse effect. Distinctive reaction that takes place when ethanol is treated with acetic acid. So this we learn next. We call it as esterification. Okay, what is this one, Dhruva?
Property of an element by virtue of its atoms of the element relative to each other. Okay. So catenation.
Hmm. Catenation. What is this one? Iona. Reaction when an alkyl halide is treated with alcoholic potassium hydroxide. What is that reaction called as? Hmm? Halogenation is the addition of any halogen. It's addition reaction, है ना? This is a preparation of ethene or ethine. So this will be called as dehydrohalogenation. Removal of hydro means water as well as halogen. Whenever alcoholic KOH is there, that is reagent, that you have to straight away go to dehydrohalogenation. Okay, so try to remember the names with special reagent what we are using, like decarboxylation soda lime, रिडक्शन के लिए जिंक कॉपर कपल इन अल्कोहल, है ना? सो डिहाइड्रोहाइलोजेनेशन के लिए अल्कोहलिक पोटेशियम हाइड्रोक्साइड. State the conditions required for the following reactions to take place. So condition here catalytic hydrogen के लिए any catalyst you can write, nickel catalyst. Okay, and temperature 300 degrees Celsius heating. Ethine from ethylene dibromide. See here, common name they have given. Ethylene dibromide is C2H4Br2. So here you are getting ethine. So here the reagent we need here is alcoholic potassium hydroxide and heating we require. Identify the gas evolved. Sodium propanoate with soda lime. Which one, Dhanish? What gas?
CO2,
What is the name?
carbon dioxide, I'm not sure.
What is this method is used for?
If the production of ethene, I think, or ethane.
Hmm. Okay. Decarboxylation. Decarboxylation we use to prepare only alkanes. Right? Alkanes mean you are preparing only methane and ethane. That's it. Methane you want to prepare, you want to have sodium acetate. This is not sodium acetate. This is sodium propanoate or propionate is a common name. Propanoate, if they give you, that is IUPAC name.
Okay.
CO2 you will not get here. You will get ethane. है ना? Byproduct is sodium carbonate, which is not a gas. CO2 will not form here because the name decarboxylation is not CO2 forming here. ठीक है? Balanced equation saturated hydrocarbon from iodomethane. Iodomethane is CH3I. From this
So,
saturated, you will get CH4. Yeah.
so the previous one, what is the IUPAC?
Previous one,
Sodium propionate.
propionate is a common name.
Oh,
Okay.
oh,
If it
sorry.
is propanoate, it's IUPAC. Ethanoate, IUPAC.
Okay. Okay.
Okay. Wait. Here we do use the zinc copper couple in alcohol plus HI. Okay, unsaturated hydrocarbon from an alcohol, so it is dehydration of ethanol. So ethanol say ethene, right? Conc H2SO4, 170 degrees Celsius. Unsaturated hydrocarbon from calcium carbide, CaC2 water, CaOH2, C2H2. So I think it is not balanced previously. 2H2O. Suitable chemical terms. Aryan, you found
Yes,
it?
sir.
You found it?
Yeah, sir, I found it. I found it.
What is it?
It's calcium oxide plus carbon, which gives calcium carbide and CO
Okay.
plus 3C and 2000 degrees Celsius.
Mhm. Calcium oxide से okay, fine, ठीक है. But that will not be asked. But they may give in a question. The product formed when calcium oxide is heated with carbon reacts with water to form an unsaturated hydrocarbon. So like that. Sometimes, very rarely. Okay, a reaction in which hydrogen of an alkane is replaced by the halogen. Chanvi, what is this? Chanvi, Ruhani?
Sir, can you hear me?
Yes, Chanvi, I can hear.
Sir, halogen,
Replaced by a halogen. Alkane के लिए you don't call it as halogenation. Alkane में only substitution. Remember? Hmm. So you guys are having confusion. So make it clear, na? Right? In the alkane, what type of reaction it undergoes? Substitution. Alkenes and alkynes undergo addition. Addition may you will have halogenation or hydrogenation, chlorination, bromination, etc. State 1 observation, bromine vapors are passed into a solution of ethyne in carbon tetrachloride. So reddish brown color of bromine decolorizes. From the list we have to select the things. An unsaturated hydrocarbon used for welding purposes. I told you if there is welding it is ethyne. Okay. Functional group is carboxyl. Carboxyl is COH group. Okay, here acetic acid. From the list, it is acetic acid. Catalytic hydrogen gives a saturated hydrocarbon. So if you do ethene, okay, an organic compound used as a thermometric liquid, ethanol. Mercury was used earlier, but mercury is found to be poisonous. So nowadays they use ethanol. Okay, this one we know, nickel. Write the equation for the reaction taking place between 1,2-dibromoethane and alcoholic potassium hydroxide. So when there is a two bromine atoms, your product will be ethine. Okay, C2H4Br2 KOH alcoholic. To remove two bromine atoms, you need to have 2 KOH. है ना? So 2 KBr 2H2O C2H2. This is your equation. Heating symbol should be there. So here monochloroethane is hydrolyzed with aqueous potassium hydroxide. This is your alcohol preparation. We'll see that. Monochloro means single chlorine. So it's nothing but chloroethane only. Mixture of soda lime and sodium acetate is heated. You will get methane plus sodium carbonate. So see, for 4 marks they have asked all the common names. How do you convert ethyl chloride to ethyl alcohol? Ethyl chloride to ethene. Ethene to ethyl alcohol. Ethyl alcohol is what? Ethanol only. Okay, ethyl alcohol to ethene. So only these some things we have to go through. Name the organic compound prepared. Okay. Who knows the first one? Raise your hand. Yes, Ruhani.
Sir, ethane.
Very good. Second one, who knows? Iona.
Ethane.
Second one.
So methane.
M.
Methane.
Methane. Okay.
Sir, shouldn't that be in brackets, the hydrogen?
It should be bracket. Next one, whoever knows answer, right? Tell me. Just tell it. Hmm.
Ethanol.
No, alcoholic solution you are using, no?
So methane only. Methane. No, ethane. Sorry, ethane. My bad.
Not ethane. We don't use KOH to prepare alkenes.
Oh yeah.
Ethene.
Ethene.
Last one,
Ethyne.
ethine. Right. Okay, IUPAC names for these structures. This I have included for practice during classes. ठीक है. So we'll take a short break. After that, we'll take the last part of this alcohols and carboxylic. Okay, so the last part about organic chemistry is alcohols and carboxylic acids. So in this, these are very simple concepts. I mean, not much reactions are here. See, few reactions which are very important. Okay, so first thing, how can we prepare ethanol? So first of all, see, alcohols, they are also homologous series. Homologous series means we have seen similar chemical properties, similar structures. Successive members differ by a CH2 group. They have same functional group. So alcohols all have same functional group OH. And successive members differ by CH2. Commonly we call them as alkyl alcohols. Like for example, you take CH3OH called as methanol, that is IUPAC. But common name you have to take the alkyl part, then add alcohol to it. So alkyl part here is methyl and OH is alcohol. So common name for this is methyl alcohol. C2H5OH. So this is ethyl group, ethyl alcohol. So it continues propyl alcohol, butyl alcohol, etc. So here we are studying only about methanol and ethanol, mainly ethanol. Okay. So we can get ethanol from an alkali. like sodium hydroxide or potassium hydroxide, but you have to take in water. Therefore, I'm telling you alkali. Okay. For alcoholic potassium hydroxide, we don't call as alkali. So aqueous potassium hydroxide, aqueous sodium hydroxide, they are alkalis. So with ethyl iodide, ethyl bromide, ethyl chloride. Here what happens? Here simply potassium will take away the iodine. OH will not do anything. It will just go and go along with C2H5. So you will get potassium iodide plus C2H5OH. Condition boil. Okay. Simple. Here it is not dehydrohalogenation. It is simply dehalogenation, you can call it, but let's not worry about that part. Hmm? Instead of KOH, we can also take NaOH. So here say C2H5Br I will take. NaOH. Aqueous we have to write. Boil. To remove bromine and sodium. Sodium bromide is gone. Plus C2H5OH. Ethanol. Only one method we have for ethanol preparation. But if I take the same C2H5Br, okay, instead of aqueous, if I take alcoholic, then your products are different. KBr plus water is also gone here. Dehydrohalogenation takes place. You will get ethene instead of ethanol. Okay, here also heating condition. Therefore, we have to be careful with this. So preparation of ethanol from ethyl chloride. So here wherever bromide is there, replace it with the chloride. That's it. Same reaction. Write the molecular formula of the third member of the homologous series of carbon compounds with general formula CnH2n plus 1 OH. So this is a general formula of alcohol. CnH2n plus 1 OH. How we got this? Say methane is this CH4. Methane is alkene CnH2n plus 2. In this, one H is replaced by OH. CH3, है ना? Instead of fourth H, you write OH. Then that is alcohol. So same thing. Cn, H2n plus 1, then OH. So this is general formula of the alcohol. So they have asked her third member. To put N is equal to 3. C3H7OH. Propanol or propyl alcohol. ठीक है. Properties में it's a ethanol. Alcohol is a colorless, but it has smell. Pleasant smelling liquid. Highly inflammable. It mixes with water in all proportion. You know, people drink alcohol mixing with water and other things. Boiling point is less than water at around 78. It is non-conductor, means it is a non-electrolyte. Does not contain any ions. Chemical property may same. When you burn it, you will get CO2 and water, just like other hydrocarbons. But alcohol is not a hydrocarbon. It's a derivative of hydrocarbon, right? This one we have to see that esterification reaction. Esterification. Now, what is ester? In this word, you have ester, hai na? Ester is also some kind of functional group, just like alcohol, carboxylic acid, aldehydes. Ester is also a functional group, which is C double bond O single bond O. COOH may, if you remove H, what is left? COO. That is ester group. So when this reaction takes place, we are getting esters as the products. Therefore, the name esterification. So to do esterification, we need alcohol. General reaction I'm writing here. And carboxylic acids we need, not the mineral acids. When they react in presence of a dehydrating agent, Kong sulfuric acid. Okay, this Kong sulfuric acid will make sure the reaction will not get reversed. Okay, because otherwise it is a reversible reaction. Okay, here we will get ester plus water. So whatever water is there, that is absorbed by the Kong sulfuric acid. So in place of alcohol, I will take ethanol. In place of carboxylic acid, I will take acetic acid. Condition is same, Kong sulfuric acid. Now what you have to remove? You have to remove the water. Okay. So OH from the alcohol, H from the acid you remove. OH and H. Water is gone. So after removing this, what is left here? CH3COO. From the acid part, CH3COO is left. From the alcohol part, C2H5. So this is the ester. Structure how it is there. CH3 is this one. COO how we will write? C double bond O, single bond O. Then to this what is attached? Ethyl group. Ethyl we will write CH2 CH3. CH2 CH3. So this is the structural formula of the ester formed. How do we name this? Okay. So common name is you have to start from this group. This group is ethyl group. And this part CH3COO is acetate. Commonly it is called as ethyl acetate. Otherwise, esters have the secondary suffix OAT. Okay, so you can write ethyl. This one carbon, two carbon, eth, all single bonds N, and ends with OAT, ethanoate. What is the IUPAC name for this? Ethyl ethanoate. This is IUPAC. Okay, and structural formula is this. Say instead of ethanol, if you take methanol, so you'll get methyl acetate or methyl ethanoate, right? CH3OH, CH3COOH, concentrated sulfuric acid. Remove OH and H. What you are left with? CH3COOCH3 plus water. So
Plain catalytic hydrogenation again.
why? What is the difficulty in that?
Uh, in the conversion from ethane to ethane, if we keep adding hydrogen, instead of even going to the ethane, if we add like 2H2 instead, won't we directly go into ethane?
Yeah. If you want to
Then,
convert ethane directly to ethane, then you will write the equation 2 hydrogen molecule. But actually it goes through the ethene process. First ethane becomes ethene. Then that, because ethene also undergoes the addition reaction, no? So ethene is not stable. Still you are providing hydrogen. So it further goes and forms ethene. Okay, therefore you have to write it. If you want to write it in one equation, 2H2 you have to write. Otherwise, two steps also you can write. Okay, so here this one is methyl, and this part is remaining same, acetate. Or IUPAC name will be methyl ethanoate. Okay. Here they will ask the observation for these esters. They have a pleasant fruity smell. So we can write the observation: pleasant fruity smell observed. So because of this, esters are used to prepare uh, perfumes. है ना? Chalo. So this esterification 1 mark question will be there for definite. Okay, so here because we are learning esterification, the answer should be esterification here, where you are taking acid, carboxylic acid as well as alcohol in presence of Kong sulfuric acid. Other reactions of alcohol. So with sodium metal, it undergoes simple displacement reaction. So the H of the alcohol is replaced by the sodium. So we will get a gas here, hydrogen gas. Okay, and the name of this product C2H5ONA. Whenever metal is there, you have to start writing the name from the metal. Sodium. This one is two carbons, Eth. This one is oxide because it is ionic compound. Na? C2H5 O minus Na plus. Sodium ethoxide is the name of the product. If methanol reacts, you will get sodium methoxide. And this one, dehydration of ethanol, we have already learned. Okay. So they will ask you which gas is released when sodium metal is added to alcohol, hydrogen gas. What is the name of the product formed? Sodium ethoxide and hydrogen. So here they have asked compound found when ethanol reacts with sodium. Sodium ethoxide. Balanced equation, monochloroethane, aqueous sodium hydroxide. Mono means one. Basically chloroethane. Chloroethane is C2H5Cl. Sodium hydroxide aqueous. Only here don't do dehydrohalogenation because it is aqueous. Remove NaCl. Then you take C2H5OH. Okay, uses part. Ethanol is used in the manufacture of beer, wine, and other alcoholic beverages. Not only that, it is also used as a solvent in paints, varnishes, oils, dyes. Okay, in many of the cases, it can be used as a fuel also, and other organic compounds synthesizing to as an antiseptic to sterilize the wounds. These all things. Okay, take this one. Now let's see different commercial forms of ethanol. Ethanol in the market is available in different commercial forms. First one, absolute alcohol. Absolute means what? 100%. You know. So 100% alcohol, no water mixed, which is not suitable for drinking. 100% alcohol. So we are talking about here ethanol now. So absolute alcohol is which one? It is 100% ethanol, C2H5OH. Okay. No water mixed. Where we use it mainly for industrial purposes as a solvent, not for drinking beverages. Okay, industrial purposes. But some people, what they do, they can, you know, steal these absolute alcohol bottle, dilute it with water, and sell it. Okay, such things started happening. Then what these people did, they added some impurities to this to make it, unfit for drinking. So that one is called as methylated spirit. Spirit is alcohol, or in the lab, if you might have heard spirit lamp, means the lamp which uses alcohol as a solvent. Sorry, fuel. Methylated spirit is also known as denatured alcohol. Denatured means whatever its nature was there, it has been changed. Okay. So what is this? Why this is made? So that it is not fit for drinking. So here, alcohol is a colorless solvent or colorless liquid. So first of all, they can make it unfit by making it look like it has some color. Okay, so color, they can add some dyes, or they may also add copper sulfate solution. Okay, copper sulfate, because it is mixed with alcohol, it will give you a blue color. Then methanol they will add, methanol or methyl alcohol. Now ethanol we can drink, but methanol is a poison. Methanol should never be, you should never drink it. So if you drink, then you may die. It's highly poisonous. It causes blindness also if it falls on the ice. So whenever we are using methanol in the lab, in future, if you do any chemistry and all, if you're taking in industries, we have to use goggles, safety goggles. So methanol will be there, and color dye and some pyridine they will add. What is a pyridine? Pyridine is some organic compound which will give it a bad smell. Okay. So basically we are giving some color, some smell, and also mixing some poison so that people should not drink it. Okay. So usually 5% we add methanol. Okay. Lastly, you can see the last one, spurious alcohol. Spurious alcohol is actually made by improper distillation. It is not done in industries. It is done by some people illegally, usually in the villages and all. Spurious means it is not good, you know. So mainly when they do, there is a process for making these things. So distillation we do. In that process, along with ethanol, there will be large amount of methanol mixed with that. In that process, it is formed. So by drinking spurious alcohol, people lost their lives. So that is another kind of alcohol, but it is not commercially available, but it is done illegally. Okay. The organic compound mixed with ethanol to make it spurious is methanol. Actually, not spurious, it is to make it denatured. End product, okay, leave this. Last one, carboxylic acids. Carboxylic acids. So the functional group here is COOH. We have already learned how to name this. Common name, formic acid is the first member. Second member is the acetic acid. Does anybody know what is the IUPAC name for formic acid? Formic acid. Hmm? Nobody knows what is the IUPAC name for formic acid? Methanoic acid. Right. Methanoic, ethanoic. Okay. So basically, we are learning only about the acetic acid in this case. So it is the second member of the carboxylic acid family, and usually it's naturally occurred in vinegar. It has a vinegar smell. It smells like vinegar. Because it is acid, it has a sour taste. But in pure state, it is colorless and a corrosive liquid, just like other acids. Also, it can mix with water and alcohol, and we have seen the reaction between carboxylic acid and alcohol, right? This point is important, the glacial acetic acid. So why this name is given to it? Glacial is actually it's a pure acetic acid. When it is cooled to its below its melting point, that is 17 degrees Celsius, it starts forming the solid. That solid looks like ice glaciers. Okay, ice like mass floating on the surface means give the appearance of glacier. Hence, they started calling it as glacial acetic acid. Okay, which is actually in the pure state, not mixed with water. And pure acetic acid is also hygroscopic liquid, means it absorbs the moisture. So this is a question they have asked. So here you have to write glacial acetic acid. Don't write pure. Glacial acetic acid word you have to use. Chemical properties may, if you come all the typical acid reactions what we have learnt, it is shown by acetic acid also. No need to learn them separately. Because it forms H plus. But it is a weak acid compared to mineral acids. So we can see here with metal carbonates, bicarbonates, we get CO2 gas. With base, we get salt and water. So salt here is sodium acetate, which is we used to prepare methane gas. And with metals like sodium, magnesium, zinc, it forms hydrogen gas. Respective salt plus hydrogen gas. Typical acid properties. And this one we have learnt already, esterification. Same reaction. Observation for the esterification will be pleasant fruity smell. Fully balanced equation for the following case. So again, same thing. Acetic acid is CH3COOH. Ethanol is C2H5OH. On the arrow, we should not forget to write corn sulfuric acid. Warmed. ठीक है, little bit of heating. So what you have to remove? H from the acid, OH from the alcohol. So we'll be left with CH3, COO, C2H5 plus water. This is a balanced equation. Uses part, ठीक है, mainly vinegar, to prepare vinegar, to prepare other organic compounds, and it is also used as a laboratory reagent. If you go to lab, you might have seen acetic acid bottle there. So that's called as laboratory reagent. Removal of CO2 by heating a carboxylic acid is called decarboxylation. Not only this, but any way we are changing carboxylic group into CO2 gas or some other carbonate, okay, that will be called as decarboxylation. So here give reason they have asked. So you have to write, when you cool it to below its melting point, that is 17 degrees Celsius, it forms ice like solid, which looks like a glacier floating on the water. So therefore it will be called as glacial acetic acid. What type of compound is formed? Here type of compound you have to write ester. You know, esterification में ester we get. A gaseous hydrocarbon commonly used for welding purpose. So welding के लिए acetylene gas or ethane gas. Structural formula ठीक है. Okay, odd one out again, depending upon whether it belongs to same homologous series or different. We have to separate it. So I think C5H8 will be the one. Okay. Aryan, can you read this?
Yes, sir. Can you hear me?
Yes.
Hydrocarbon gas having one carbon atom in its molecule is collected by the downward displacement of water. It burns with a blue flame and the resulting gas turns lime water milky.
One carbon containing hydrocarbon, which one is that?
One. So methane.
Correct.
Methane.
Hmm.
So, but they're asking lime water milky, no? So,
They have asked hydrocarbon. It burns. They're talking about hydrocarbon only.
resulting gas. Okay, okay.
ठीक है. State its two properties based on the above observation. So two properties. Okay, what you will write if they ask you this? Tell me.
Corrected by downward displacement.
So that tells us what?
So it's not soluble in water.
Yes, very
I mean,
good.
insoluble in.
Yes. Any other point?
This the burns with a blue flame. That means it's inflammable.
It doesn't.
So it's not. They're flammable. It's not
Okay, it's flammable gas. Okay, physical properties. Chemically, we can say that it produces CO2 gas on
or you
burning.
can say it's highly reactive gas. Something.
No,
It's also known as
reactive gas we can't say. Huh. No, no. You are can't write here marsh gas because it is not the properties, no? You know. So yes, one, it is by downward displacement matlab it is not soluble in water. Second one, based on the resulting gas, that is CO2. We can say it chemical property you can mention, you know, that it will form CO2 gas on burning. Okay. Hmm. Who will okay, Darshwana, can you read and tell the answer?
Yes, sir. A compound is formed by the substitution of two chlorine atoms for two hydrogen atoms in propane. What is the number of structural isomers possible? Name them.
Okay.
Sir, three.
Hmm. Okay. So first of all, what will be the formula for that? Whatever they have asked that compound formed. प्रोपेन में प्रोपेन इज
size. Oh, sorry, three. Sorry,
C3H8
that's
ना.
that.
हाँ, so
Uh,
इसमें से 2 hydrogens are removed by chlorine. So C3H6, 2 hydrogens, correct? हाँ,
yes, sir.
Cl2. So this is the molecular formula we are getting. So you have to try writing different isomers. Okay, it depends how many it will come. We don't know. Let's try. Hmm? To one, I will write straight CH3, CH2. Okay, we need to put chlorine here. You know? So here one Cl I will put here, another CH2Cl. This is one possible isomer, correct? Now CH3CH, I will change the position, ClCl CH3. Another possibility, CH3C, then give chlorine to this one only, and one H, so H and H, CH3 CH2 CH Cl2. Any other possibility? First and third carbon we can write now. First Cl, third Cl. This is possible. 1, 2, 3. So here two hydrogens. Here two hydrogens. Okay. Any other possibility? We can't reduce the number of main chain carbons. Can we reduce? No, it's not possible. Okay, 1, 2, 2, 2, 1, 1, 1, 3. These are the four isomers possible. Any other possibility? If it is there, we have to. No, it is not possible. So we have to name these. 1, 2 dichloro propane, 2 dichloropropane, 1 dichloropropane, 1 dichloropropane. All of these are what type of isomers? Chain or position?
Structural
Under structural, chain or position?
position.
All of them have same carbon chain. Therefore, the position of the substituent is different. See, these kind of question, if they comes, Dashman, I can mute. If these kind of questions comes in the exam, you should be able to write only when you understood the concept. Otherwise, if you just remember the butane isomers, pentane isomers, then gone. Okay. But those are commonly asked. Means most of the time that will be asked. Therefore, we have to practice that. Along with that, we have to start, understand the concepts also. Okay. Write the chemical equation for the reaction. Okay. Same esterification reaction characteristics. These kind of question now they don't ask you. State three characteristics of isomers and all. Hmm? But two at least they have same molecular formula, different structural formulas. Last question. Okay, laboratory preparation of methane. Say we didn't study these structures, diagram and all, but we know what is the equations. So name X and Y. Inverted jar. So since they have asked here the mixture, so we can write the first method, sodium acetate plus soda lime. Okay, sodium acetate plus soda. So that is the mixture here. Y will be methane gas because that is what they are preparing. Balanced equation. Methane is collected by downward displacement of water.